In this video, I'm going to talk about boundedness and symmetry of a function. So first, let's take a look at the boundedness. What is bounded below function, bounded above function, or a not bounded? So we are let's take a look at the definition. A function is bounded below if there is a some number b that is less than or equal to every number in the range. That is the important word. That means we are looking at the y value, and boundary of y value means how maximum and minimum, or how where it is going, or if it is not going, what number it is, and that's what the boundedness is. So here, let's take a look at this example, bounded above and below. So you can see that this is the trig function. The maximum value is a 1 and minimum value is negative 1. So this trig sine and cosine functions are called bounded above and below. Now let's take a look at the parabola here. It's upside down parabola, and you can say that the maximum value is a 3. That's the maximum. So this one you can say bounded above because there is no y value here. The boundary is a 3 maximum. Maximums are bounded above. Here it goes to negative infinity. So negative infinity to 3, and that's called bounded above. Similarly, bounded below is minimum value is, you can say this 0 or negative point something. So this is the minimum. There is no y values here. That's why bounded below. Some graphs are not bounded because it goes to positive infinity and it goes to negative infinity. Now there is no such thing as bounded in the middle. So there are four categories of bounded: above and below, above, below, and not bounded. Now, looking at the graph is very easy, but you will have to know how to do from the equations also. So, for example, f of x equal to x plus 2. So, you can sketch the graph and check it out that this is a line. It goes forever to infinity and negative infinity. So, this function is not bounded. Okay, so 3 to the x. We know this is exponential function. Exponential functions could be growth or decay. Here you can see that the 3 is greater than 1. So this is exponential growth function. It goes to infinity and the minimum number is a 0. So this is considered as bounded below. There is no y values here, so that's why bounded below. Now 3 minus x squared, in fact, this is the same graph here. So I'm going to look at another example. This is the same bounded above. You can say that what happens if it is a 3 plus x squared, which would be 3 units up, and you can say that that's a bounded below, bounded above, bounded below. Now what happens if it is f of x is x cube? Well, we know that the cubic function looks like this, and all the cubic functions are not bounded because they go forever up and down. So boundedness is very easy feature of the function. You can see that above, below, not bounded, or above and below. Now I'm going to talk about the symmetry of a function. This is a very, very important topic. You have to be able to identify the symmetry without a graph and with a graph. So let's take a look at the definition of even function. Even function is symmetrical with respect to y-axis. So for example, if I have x and y, symmetrical with respect to y-axis is I should have a similar point on the other side where x becomes negative, y is still same. So algebraically, you must know that if f of x is the same as f of negative x, understand this again, x value is replaced by negative x becomes negative x, you still have the same y value is still same. then it is called even function. Most popular are parabolas. Now, the basic parabolas are even, but they are shifted. They are no longer even. They don't hold the characteristics. Okay. Odd function. What is odd function? Is symmetrical with respect to origin. So let's take a look at the example here. Algebraically, graphically, both ways. If this is a point x and y, odd function symmetrical with respect to origin means you go 180-degree opposite direction, and this is where x is negative and y is also negative. Odd function, 180-degree you rotate, x becomes negative x, y becomes negative y. So this is the algebraically, you replace x with negative x, the y value also change the sign, and that makes it odd function. All the cubic functions are odd functions. Now, very interesting to notice that for odd function, if you have in a second quadrant, then you must have in a fourth quadrant. So that means exactly you go 180-degree in opposite direction to make it odd function. Symmetrical with respect to x-axis. Of course, they are not a functions, but let's understand the symmetrical with respect to x-axis. That means if I have a function x and y, then if I have x, it becomes negative y. And let's talk about why they are not a functions, which means if x walks in, once you get a positive y, if the same x walks in, you get the negative y. That means something's wrong with the machine and they are not functions. Let's take a look at the examples here. And you must know how to do algebraically, and you have to follow the directions and answer the question. It says find f of negative x. That means you must find f of negative x. Then determine if it is odd, even, or neither. So first of all, let's replace x with a negative x. And you get negative x square minus 1. We know that the negative x and you are squaring, it is still same as positive x square minus 1, which is the same as the original f of x. Again, f of negative x is the same as f of x. Here, this f of x function is a even function. Replace x with a negative x, you get the same as the original. That means f of x is an even function. Let's try again. F of negative x. Replace x with a negative x. Be careful here. This is a parabola. It's not even function because it is shifted. But we have to still prove algebraically. So factor out the negative sign. And now here negative number square becomes positive. So here if we replace x with a negative x, the whole x plus x minus 2 square becomes x plus 2 square. So this is not the same. This is not the opposite sign. So we can say f of x is not same as f of negative x, or which is not even same as negative f of x. And therefore f of x is neither, whichever way you pronounce it, is not even, not odd function. Okay, you can support graphically if you want that this graph is shifted here, and you can see it's neither. This parabola shifted 1 unit down, and you can still see that that's the even function. This is only for to check. You must do algebraically. So let's take a look at one more here. F of negative x is negative x cube plus negative x divided by negative x to the fifth power. We know that the negative number to the third power becomes negative. Negative number to this one power is negative, and the fifth is also negative, and which is the same as if you factor out the negative, then this is the same as negative f of x. Now clearly you can see that the negative sign came out. So that's why this is odd function, because this everything is exactly opposite sign, positive positive positive, negative negative negative, exactly opposite. That's why it is an odd function. This is an exponential function. We know that the exponential functions are neither, but we still have to do our job and support our work. You can say that this is not same as f of x, and it's not even opposite sign. Clearly this is a growth function. If you replace with a negative x, it becomes a decay function. They are never going to be same or even reflection. And you can say that f of x is neither. So this is all algebraically. Now make sure you do the homework page, and you have to find f of negative x and then determine or even neither.